All right, so this problem wants us to use partial fractions to evaluate the following interval. This is actually something we can do with a pretty easy use substitution, which I'll do at the end, but let's try it. Let's try it the way they want it. All right, so let's start over here. So first of all, x over x squared minus 4. Well, this is an x squared minus a squared situation where a is 2, so that equals x over x minus 2 times x plus 2. And now using partial fractions, I can rewrite this as some a over x minus 2 plus some b over x plus 2. Okay, so I will do what we did before. I will multiply each side. By x minus 2 times x plus 2. So what happens there on the left? Well, we're just left with the x. On the right, the x minus 2's cancel. Then I have a times just x plus 2. And similarly, I have b times x minus 2 because the x plus 2's cancel. So this equation here, you can think of this can be rewritten as 1x plus 0. When I distribute the a into there, I get ax, and then I get a bx, so then I should have a plus b equals 1, since there's 1x. And when I distribute it for the coefficients, I get 2a minus 2b, and that needs to equal 0 since we have 0. Our coefficient is 0. Well, I can solve this using substitution, or I can just add 2 to the top, but let's use substitution. Let's make this equation 1 and equation 2. So using 1, we have a equals 1 minus b. I'm going to sub into 2. So that means 2, and a is now actually 1 minus b. Minus 2b equals 0. And that means I have 2 minus 2b minus 2b equals 0, and that's negative 4b equals negative 2, or b equals 1/2. And then using 1, I get a plus 1/2 equals 1, or a also equals 1/2. So now I'm going to rewrite this here. So this is equal to the integral of, since it's 1/2, it's going to be 1 over 2 times the quantity x minus 2 plus 1 over 2 times the quantity x plus 2. All of this is dx. We have to keep that there for notation's sake. We can break it into 2, certainly. I can just pull out a 1/2. So 1 over x minus 2, and then 1 over x plus 2. Well, the u in each case will be what we have in the denominator. The du is just 1, and we're left with essentially, that'll be the natural log. So 1/2, we have ln of absolute value of x minus 2 plus ln of the absolute value of x plus 2. And then, plus c. Let's write that a little cleaner, sorry. In fact, let's just do this, and then plus some c. Using our rule of natural logs, I've got the sum of 2 natural logs. That means I can multiply those things together, so that equals 1/2, and x minus 2 times x plus 2, well, we know it's that x squared minus 4. And then plus some c. So that's what we have, and that's our answer. Now, if we were just going to do this as a normal fraction, let's grab a different color. Looks fine for now, I guess. Okay. We know that the integral of x over x squared minus 4, we can just let u equal x squared minus 4. That makes du equaling 2x dx, which means dx equals x over 2 du, or I guess more to the point, that's probably wrong to write. So I guess x dx will equal that. So x times dx will equal du over 2. So we have a dx and so forth, so that's where we get over there. So that means we have 1/2 integral of u to the negative 1 du, which is 1/2 ln of the absolute value of u. And when we replace it, it's 1/2 natural log of x squared minus 4. And that's the same answer as up here. So again, we went through a whole bunch more work to solve this problem, but again, this is a precursor for problems that you're just not going to be able to solve using a u substitution.